Okay, so you'll want to pause the video and try these two problems on your own, and then when you're ready to check them, we'll go over them together when you resume the video. So for which of the following functions is the limit as x approaches infinity of the function f equal to 0? So when we look at example 2, this is a rational function with polynomials in the numerator and denominator, and the highest degree term is 4x cubed in the numerator. The highest degree term in the denominator is 5x cubed, and in our acronym Bobo, Botan, Eats, DC, the exponents are the same, so we would divide the coefficients, and 4/5 would be the limit, and that's not equal to 0, so it's not going to be this function. In example 3, again, we have polynomials in the numerator and denominator. Degree of the numerator is 1, that's linear. The denominator is factored, and if we were to FOIL these together, these two binomials, we'd have an x² in our denominator. So the degree of the numerator is smaller than the denominator, and in Bobo, Botan, Eats, DC, bigger on bottom 0. So this one does have a horizontal asymptote at 0, so the limit as x headed to infinity would be 0 for 3. For 1, we have an e to the x in the denominator, which means we need to graph this and take a look at the table to be able to evaluate that limit. So in the numerator, we have a 3x minus 5. In the denominator, e to the x power, and since that's an exponential with a natural base, there is no value of x that would cause the denominator equal to 0. So there are no holes or vertical asymptotes. So let's look for a horizontal asymptote. When we do zoom 6, we see the curve is coming up here, bending, and it looks like it might be coming over the x-axis. Let's go ahead and adjust our window settings so we can see a little better what's going on there. So we'll change our y minimum from -2 to 2. There we go. Oh, so that's interesting. It's coming up and then over, but bending back down. Now remember, graph can cross the horizontal asymptote except at the ends. The horizontal asymptote only affects end behavior. So it's fine that the function is crossing the 0 here, y equals 0 early on, but as x heads to positive infinity, it looks like it is indeed coming back and approaching 0. Let's look at the table of ordered pairs so we can see what's going on here. So at negative values of x, we have negative values of y. Then we switch between 1 and 2. We go from negative to positive, so that's that real 0 that we saw in the graph. And then as x increases, it looks like we're getting closer and closer and closer to 0, but we're never going to cross into negative numbers again. So this function in number 1 is also approaching 0 as x approaches infinity. So since 1 and 3 work, that would be D in our multiple choice question. Okay, next, write the equation of a function g of x where the limit as x approaches infinity of g of x is 2/3. So that would mean that the degree of the numerator and degree of the denominator are the same. So we'll have g of x equals, and our leading coefficients are going to need to be 2 and 3, and the degrees need to be the same. And then as x approaches -1 from the right side, we're going down to negative infinity. So that means we need to have a vertical asymptote at -1. So if we made this a 3x plus 3, then that would cause a vertical asymptote at -1, because 3 times -1 is -3, plus 3 is 0, and that would be a vertical asymptote when the denominator equals 0. Okay, then in the numerator, we need the degree to be the same, so we'll make this a 2x, and then let's take a look at what that graph is doing. So numerator is 2x divided by our denominator 3x plus 3. We'll do a zoom 6. And here we can see at -1 from, was it the right or the left? -1 from the right side. We're coming along this way from positive infinity, and we are in fact bending down to negative infinity. So that works for our second limit statement. And the limit as x approaches infinity, that's headed off to the right side, should be 2/3. And when we look at the table of ordered pairs, so starting here at negative numbers, we're going to head toward positive infinity, and we're getting closer and closer and closer to what number? So it looks like we're getting closer and closer and closer to 0.66, and 2/3 is 0.66666 repeating. So we with this function 2x over 3x plus 3, we satisfy both limits.